In this module, we'll build a clear mental model of the EUDI Wallet journey. We'll follow a user through onboarding, see how their wallet holds and presents credentials, how a relying party consumes them, and how back-end verification, trust, and KYC systems securely plug into that flow. You now have the core pieces needed to think like an eIDAS 2.0 architect. You understand why trusted digital onboarding matters, who the key actors are, and the precise language we'll use for wallets, credentials, and trust. Now we'll assemble those pieces into a single end-to-end onboarding journey. Think of it as a blueprint, how a user, their wallet, issuers, and relying parties interact from first contact to approved access. View the EUDI Wallet journey as an end-to-end system, not just a front-end flow. A user's action triggers wallet interactions, which pass identity data and consent into verification and trust services. Those results feed KYC decision engines that approve, reject, or escalate. Along the way, audit and monitoring capture evidence, while operational controls enforce security, privacy, compliance, and resilience. Good architecture keeps this whole chain predictable, explainable, and trustworthy. Here's the big picture of an EUDI wallet-based onboarding. A customer starts in a web or mobile channel and chooses the wallet as their identity source. The relying party then requests specific attributes, and the wallet presents them for the customer to review and approve. Approved, verified attributes flow into verification services, trust and fraud checks, and any case review. Together, these drive the final KYC decision: approve, decline, or route for manual handling. Now we're turning abstract roles into concrete systems. The customer lives in channels like browser, mobile, and wallet, but the relying party owns the onboarding platform, workflow, and KYC outcome. Before any data reaches core systems, a verifier capability checks credentials and proofs. Behind that, traditional back-office services handle decisioning, customer records, risk, audit, and case management, keeping compliance and operational ownership clear. Onboarding actually starts in your channel, not in the wallet. The user begins their application, then explicitly chooses the EUDI wallet as their identification method. From there, you orchestrate the handoff, maybe a QR code from a desktop browser or a deep link or app redirect on mobile. The crucial part is preserving a secure, continuous session, so that when the user returns, data sharing feels intentional, traceable, and safely bound to that original context. The wallet acts as a privacy boundary between the organization asking for data and the customer's credentials. A relying party can request specific attributes, but the wallet mediates that request. The customer reviews who's asking, why they need the information, and which attributes are involved. They can choose to disclose only what's necessary when supported by the credential format. Only after consent does the wallet send a verifiable response back to the relying party. At this point, you're balancing two verification patterns. In an embedded model, the relying party runs verification logic itself. That gives tight control, fast decisions, and fewer moving parts. But it demands in-house expertise for signatures, trust lists, revocation, and policy. With an external verifier, you gain specialization, scalability, and vendor updates. But you introduce integration complexity, vendor dependence, and shared incident duties. In both cases, the relying party still owns the business decision. Once the wallet has been verified, that's just the starting point. The verified attributes are pushed into a KYC orchestration layer which chains together identity verification, risk scoring, sanctions and fraud checks, and your own business rules. Those services collectively determine the outcome: approve, reject, ask for more data, or send the case to a human. Finally, that decision updates downstream systems like CRM, customer profiles, or core banking. When a wallet presents a credential, two things must happen. First, you prove it can be trusted. The data hasn't been tampered with, the signature verifies, the issuer is trusted, it's not expired, and it hasn't been revoked. Second, you prove you followed your own rules. You log what was requested, the result, the user's consent, and the onboarding decision, while storing only the minimum data needed for compliance. Every boundary in this architecture changes who is accountable for what. At the browser or mobile boundary, you're dealing with user-controlled devices, so you design for untrusted endpoints and strong session protection. At the wallet boundary, credentials live outside your direct control, so you rely on standards and agreements. Your backend boundary is where you fully own security and operations. Beyond that, cloud and third parties require contracts, audits, and continuous assurance. Designing wallet onboarding in the cloud means drawing very clear ownership lines. Your cloud provider gives you compute, network, storage, identity, and monitoring. But you own how those are configured and how data flows through them. Every third-party verifier, registry, AML, or fraud service introduces risk. For each dependency, you must define data residency, encryption, private connectivity, logging, resilience, compliance obligations, and, importantly, how you would exit or replace that vendor. Verification then becomes a classic build, buy, or partner decision. Building gives you maximum control and customization, but you own engineering, uptime, and most of the compliance work. Buying a product speeds delivery and brings mature integrations, yet you accept vendor constraints and some lock-in. Partnering with an orchestration layer adds flexibility across multiple providers at the cost of more architectural complexity. Choose based on assurance needs, interoperability, audit requirements, scalability, cost, and who owns risk long-term. Here you're locking in how trustworthy, compliant, and operable your onboarding platform will be. First, design consent so you can prove exactly what a user agreed to, what data moved, why, and for how long. Next, decide how much evidence you truly need and define deletion rules that satisfy both AML and privacy regulators. Finally, pick a deployment model, then capture each choice as an architecture decision record to keep governance clear. You've now seen how an eIDAS 2.0 onboarding journey links customer, wallet, relying party, verifier, and backend decisions into one trusted flow. Architecture choices around boundaries, ownership, consent, and evidence aren't technical details. They shape risk, compliance, and cost. In the next step, we turn this architecture into a concrete onboarding use case.